Students, good morning. And now the class 11 physics, that is system of particles and rotational motion. We are going to discuss about the second part of system of particles and rotational motion. In the previous video we had discussed about what are the system of particles, what is the rigid body, what is the definition of the rigid body, how a rigid body can be considered as the system of particles, which type of bodies can be considered as rigid bodies and which type of bodies cannot be considered as rigid bodies. After that we had discussed about different types of motion. What are the different types of motion a body is executing? In that case we had discussed about the pure translational motion. After that we had discussed about the pure rotational motion, and after that we had discussed about the precision. And the next type of motion we are going to discuss at this time in this video is different kinds of motion of a rigid body, that is the part 4 of different kinds of motion of the rigid body, fourth type of motion. The fourth type of motion is what a body is executing pure translational motion and rotational motion. Body is executing pure translational motion and rotational motion. Pure translational motion and rotational motion. For this I am taking an example. Look at the example here. This is an inclined surface. And a body is situated at the top of the inclined surface. There are different points. Suppose this is P1, P2, P3 and P4. These are the different points on the system of particle which is on the top of the incline, and if this system of particle on the top of the incline is made to move at the bottom of the incline, then the different particles execute different velocities, and if it is going to be rolled, then they are executing different velocities at a different time. Suppose this is moving like this, okay, and moving like this also, in the inclined plane moving like this also. So if this body is moving without slipping, then in this case this point P4 without slipping, then this point P4 also moves with different velocity, point P3 also moves with different velocity, P1 also moves with different velocity, and P2 also moves with different velocities. These objects are moving on the inclined plane. But if this body slips, slips means this point is being fixed. This is P4 point, and this point is the fixed point. Then this point is the fixed point, and the other points are moving with different velocities. So with slipping, the velocity of point P3 will be 0, and P1, P2, velocity of point P4 will be 0, and P1, P2 and P3 are moving with different velocities. So this is the translational motion. If the body is moving without slipping, and if the body is slipping and rotating as well as slipping. If the body is rotating rotating plus slipping, rotating plus slipping, then this combination of motion is called as rolling motion. This is called as rolling motion. We will discuss about detail about the rolling motion in this lecture. At the last there is a rolling motion in which we will discuss about the movement of different points of the body when the body is rolling on the surface. So when the body is executing pure translational motion and rotational motion, we had discussed both type of motion. Translational motion means the body is moving with velocity v, and rolling motion, rotational motion means moving along the axis. If these two motions are combined together, translational rotational motion plus translational motion, that is slipping motion, that is, it can be also considered as translational motion. Translational motion. So these two motions combine together to give the rolling motion, and the body is rolling on that surface. So these are the different type of motions we had discussed. Now in this video we will discuss about the term that is called as center of mass. The next discussion is center of mass. One example of rolling motion is that, students, one example of rolling motion is that, suppose this is an inclined plane, and we had moved the chalk like this. This is inclined plane and this. So what you are seeing, what you are observing, the chalk is rotating on its own axis, as well as the points are moving in a straight path also. The points are moving on the straight path also. Just like the movement of the tires on the road. What will you see? The tires of your vehicle is rotating in an axis as well as moving on the straight track. So this motion is called as translational motion plus rotational motion, and that motion is called as rolling motion. Clear, students? This is about rolling motion, and about rolling motion we will discuss in the last of the chapter. There is a topic about rolling motion. So let us understand about center of mass. Center of mass. Before discussing center of mass, I am describing you about the center of mass with an example. Look at here. This is a body. Suppose this is a body, and what we had done, I am trying to make it. Look at here. I am trying to make it to fix over our one finger. I am trying to make it to fix on, it is not going to happen. But you had observed that various times it will happen that any object is being fixed. Look at here, just like that. I had applied the force at any one point of this chalk, and the chalk remains stationary at this point. It means to say that what? It means to say that the whole mass of the chalk is being concentrated at this point. Means for any rigid body, we can suppose that the whole mass of the system of particles is being considered at a particular point, and whatever the forces applied on the body is supposed to be applied at that point. And that point where it is supposed that the whole mass of the body is being concentrated is called as the center of mass of the body. So we can define the center of mass of the body as the point on the body. Body, if I am saying, means rigid body, means rigid body, rigid body. The point on the body where it is supposed that whole mass of the body is being concentrated. Whole mass of the body is being concentrated, and whatever the forces applied on the body is supposed to be acted at that point of the body is supposed to be acted at that point of the body is center of mass of the body. That point is called as the center of mass of the body, where the whole mass of the body is being supposed to be concentrated, and whatever the force is being applied on the body is supposed to be acting on that point, and that point is called as the center of mass of the body. Each and every body have its particular center of point, but it is up to us then that how to find the center of mass of that body. Clear, students? So let us describe the center of mass of the body by taking an example of two particle system. So we are going to discuss about the center of mass of a body for two particle system. Center of mass of the body for two particle system. Center of mass of the body for two particle system. Center of mass of a body for two particle center of mass of the body for two particle system. Now we are going to calculate the center of mass of the body for two particle system. So dear students, for two particle system we have to calculate the center of mass, and look at here. Suppose this is y axis and this is x axis. Okay, if a system has only two particles, then suppose this is particle 1 having mass m1 and this is particle 2 having mass m2. Clear? Now this is the origin, and from the origin the mass m1 has the distance x1 and the mass m2 has the distance x2. m1 has the distance x1 from the origin and m2 has the distance x2 from the origin. Then we can consider the center of mass of this two particle system in the midway between these two particles. Center of mass of the system in the midway between, if they are the equal masses, then the center of mass will lie in the middle of these two masses. The center of mass will lie if m1 and m2 are two masses and M1 is separated at a distance x1 and M2 is separated at a distance x2, then if M1 and M2 are two equal masses, then its center of mass will lie at a distance x cm from the origin. Center of mass x cm. So we are interested to calculate the position of the center of mass from the origin. We are interested to calculate the position of the center of mass from the origin. So position of center of mass from origin is given by what is the position of the center of mass, that is xcm. xcm is the position of the center of mass from the origin, and it can be given as the product of mass m1 and its separation from the origin, that is m1 x1 plus the product of mass m2 and its position from the center m2 x2 upon m1 plus m2. Similarly, this is the xcm. Since the object is lying on the x-axis, so we had calculated xcm, and its center of mass must lie on the x-axis. Suppose this object is lying on the y-axis. Suppose this is the case. Suppose we are taking this is the case, and object m1 is lying at this position and m2 is lying at this position, and this is the distance from the origin y1 and this is the distance y2 of mass. Then its center of mass will lie on the y-axis, that is ycm, and we can say that in this case the position of the center of mass ycm is equal to m1 into y1 plus m2 into y2 upon m1 plus m2. Clear? Now if this system of mass is lying in xy plane, then what we will do, if suppose this is the object and m1 mass is lying here and m2 mass is lying here, then first of all we will calculate the position. Suppose this is x1 y1, this is x2 y2, then how can we find? Then first of all we find in this case first of all we find xcm, and xcm is what? xcm is m1 into x1, m1 into position of x1 plus m2 x2 upon m1 plus m2. Okay. Now ycm is equal to m1 y1 plus ycm is equal to m1 y1 plus m2 y2 upon m1 plus m2. So in this case we will get the center of mass on both the axes, that is x-axis and y-axis, because the object is lying on the two-dimensional plane, that is xy plane. Since the object is lying on the two-dimensional plane, xy plane, so its center of mass also lie on the x-axis and y-axis, and so in this case two center of mass, so we can write here the position of the center of mass as xcm comma ycm. We can write the position of the center of mass as xcm comma ycm. So this is the case for the center of mass. This is the case for the center of mass of the two particle system. Now in case of two particle system, if the mass, both the masses are of equal, all the masses are of equal magnitude. If all the masses are of equal magnitude, and if all the masses are of equal magnitude, then xcm can be written as m1 into x1 plus m2 into x2 upon m1 plus m2. And if the masses are of equal magnitude, then in this case m1 is equal to m2, and if m1 is equal to m2 is equal to m, then we can write it as xcm is equal to m x1 plus m x2 upon m plus m, and it can be given as x1 plus x2 divided by 2. M can be taken common, and m plus m2, 2 to 2 cancel, and it will become x1 plus x2 divided by 2. Means the center of mass on the x-axis will lie in the middle of the x-axis. That is the mean of the two positions. That is the mean of the two positions. We are going to get the center of mass. Similarly, YCM, and YCM is can be given as MY1 plus MY2 divided by M plus M, and it can be written as Y1 plus Y2 divided by 2. So YCM is the mean of the separation on y-axis, that is y1 plus y2 divided by 2. This is for two particle system. Similarly, we can extend it for n particle system, and we will discuss it in the next video. Thank you, students. Have a nice day.